Thank you all for coming. Hope you're having a great time at the conference and got some coffee. There are lots of fun videos, hopefully, in the next few slides that I'll share. I'm super excited to be here and show some of the technology that we've been working at Waymo. Let's wait for the slides to pick up and start with the video. You can hear the video, audio, I guess, but no video. So let me kind of recreate the scene here. So I'm sitting in the back with this colleague of mine who's never been in one. You can see, kind of imagine now, let's imagine, and find me after the talk, I'll tell you more. There's nobody in the driver's seat. And then what you heard what he said, hey, it's so awesome. If you play a little bit more, you'll hear me say, yeah, so much traffic. And if you know me from before, I hate driving in very dense traffic area because A, it gives me a lot of fatigue, I'm very annoyed, and if there's too much traffic, I'm late to meetings. It just is not good for my mental health. But here I'm like, hey, there's so much traffic, see how wonderful our product is. That's what you have noticed. Let's go to the next slide. Why should you listen to me? Other than I'm from Waymo, I'm Vinutha Kallem. I have spent all my career in various autonomous systems and robots across various companies and in research and academia. I love robots, and this is why I work at Waymo. Let's bring it back to Waymo about what we do here. As you can see, I love robots, right? You can really imagine why I work at Waymo. What is really cool about Waymo is just not that it's a very cool tech. It is also what it brings with us a promise of bringing mobility to people who probably cannot drive on their own, reduce incidents on the road, and generally bring up the quality of life. If you look at some of the statistics, they're very depressing, so I'll warn you. There are worldwide about 50 million incidents and injuries that are due to vehicles, and unfortunately about 1.3 million of them result in fatal deaths. This is very sad and very depressing, and a lot of the times you can see that these can be avoided. Bringing it more closer to home, in the US, about 94% of the deaths or fatalities that you see are caused due to human choices or actions. And they occur to a variety of reasons, some of which you probably will empathize or relate to or have seen around us. The primary drivers of these are speeding, people driving at high speeds when they're not supposed to, very distracted on phones, like iPhones and smartphones are wonderful like technologies, but people are also distracted with them while they're driving. Those are a severe factor here. The other one is extreme fatigue. Maybe somebody is sleep deprived or just exhausted and annoyed or whatever causes. So that does add to the dangers on the road. And then there is drunk driving. This is why at Waymo we invested very extensively in the past decade to improve the safety of the systems. This is our experience. We have driven about 20 million autonomous miles in different parts of the US. We have driven 20 billion miles in simulation in 25 different states across 13 different states. What does this mean when compared to what an average person drives during a lifetime? I think this kind of equals to about 1,000 years of human driving that a person does in a lifetime. So that's why we call our Waymo driver the most experienced driver. We also put our driver through a very, very strong, long, and extremely hard driving test. Hence the Waymo driver. The whole conversation today is going to be about how Waymo developed the Waymo driver and how we are deploying it in different places. How did we make this happen? At the heart of it, there are four main components. If you want to think of it, the first one is obviously the hardware. What did we do to bring it? The next one is software. What algorithms and what code runs this hardware? And then how do you evaluate the system and how do you deploy? I'll talk about all these four aspects, so don't worry, and you'll see ML flowing everywhere. So this is the bullseye view of our Waymo driver. It consists of a few sensors. We have LiDARs, we have cameras, we have radars, and it also has a very strong AI compute. Together, they all make the Waymo driver's hardware system. We are currently in our 5th generation Waymo driver. With each generation, we enhance the capabilities of the driver and the driver go across the stack to give more, to drive better on the road. So let's kind of dig into what sensors are there. If you have seen the previous slide, like, why do you all have so many sensors? The top frame of it is what we call a point cloud from LiDAR images. What you're seeing here are light waves that are kind of pulsating from a LiDAR coming back, and then which gives a sense of the three-dimensional, paints a three-dimensional picture of the world. You can see that you can get a pretty accurate understanding of what is there. You can see people, you can see cars, maybe if you pay attention, you will see some cyclists and so on. Then we have a bunch of cameras, which are kind of going from we have cameras all around the car, building a 360 degrees panoramic view, and that gives a sense of very depth, which enhances our understanding of the scene using semantic understanding. And then there are radars. Radars are complementary to both cameras and LiDARs and bring incredible leverage when you have inclement weather, rain, fog, smoke, snow, things like that. Why do we have all of these things in one place? Because we believe that in very complex autonomous driving areas, you need to be able to take advantage of sensors and build a completely robust sensor view. The next part of it is the software. All through the software stack of Waymo, there's a very strong ML platform that is running as a backbone to our software. There are 4 main components. There are many more, but these are probably the 4 that are key. The first one is core perception. This is where all the sensory signals are read in, and then you build understanding of who and what is there around the scene. And then there is semantic understanding. You take more than what the core perception does. Core perception tells you there are pedestrians, there are cyclists, there's maybe like a box, an Amazon box that somebody left on the road by mistake. There's a paper, things like, or a trash can that is on the side of a road. Semantic understanding tells about what is this road user trying to tell us. Are they trying to gesture at us? Are they looking at us? They're aware of us or not? Or what is going on here? What are these bunch of cones and a bunch of stop signs saying? Is that a construction zone, or is it just like a random trash? The next part of it is prediction. This is the block where we predict what other agents or road users or other objects are doing in the world. This runs very extensively on deep learning models, uses the current position and the trajectories of the things, and kind of paints a picture of what other agents might do in the future. Then comes planning. Here is where we say the car should take this path and this velocity to drive the car from the current location to its destination. All through all these things, we'll go through all of these things in a little bit more detail, and you'll see AI runs through all of them. The key to kind of even start to think of deploying or even developing these kind of systems relies heavily on the kind of evaluations you do. Waymo is safety first. So obviously safety is very key for any product like this. But that's not all. You have to worry about, are you making progress? Are you reaching the destination in a decent amount of time? Are you satisfying all the road rules? So we have a dense set of evaluations and metrics that swath this whole drive spectrum from safety to progress to compliance and just user delight and quality. These things also are used for in the dev process. They enable faster, really fast deployment and development. They're also inherently very large scale and empirical and really are able to predict what the performance is on the road. Now you have all of these things. You have a hardware, you have a software, and you have evaluations. What does this give you? You can probably relatively easily deploy. Relatively come to a system where it says, yeah, it will work in nominal cases, but driving on the road is more than what is nominal cases, right? In these kind of models, ML systems here really have to worry about long tail situations. These things are sometimes very, very bizarre. We try to create some of these in simulations, but things that we see on the road even beats the vivid imagination that many of us can have. I'm going to show a video next. I will warn you, It could be a little jarring to some of you, especially if you drive a motorbike or have really bad experience with a motorcycle. So be careful. Again, there's no person that was harmed here. There is no Waymo car involved. There's no people involved. So that's a good one. So you can see that this motorbike doesn't have anybody else. It's just going and banging into an unattended trailer. There's nobody, anything here. There's no Waymo car involved. But this is a very bizarre situation, right? But which is something that we observe on the road. It's luckily in this case that there was no human around or any life was lost or hurt. But this is something that we have to worry about when you do talk about deploying autonomous driving on road. And we at Waymo take these kind of things very seriously. So how do you build confidence in long tail? That is where real-world deployments come into the picture. We do, at Waymo, we've deployed in a wide variety of things. Here I show you where we've deployed our ride-hailing cars. We've been driving autonomously in Chandler area in the Phoenix metro since October 2020, so about 2 years. So what you do is if you ever live in Chandler or go there, hail a car like how you hail any other ride-hailing service. A car will come without a driver, pick you up, take you wherever you want. We've also done more deployments with a trusted tester program in SF and in downtown Phoenix. So those of you who live in SF might get into these quickly if you would like. So what does these real-world deployments give us? It gives us a way to test our systems, deploy our systems responsibly and test and really push the boundaries of our knowledge. Where has Waymo driven? You've seen cars probably if you live in SF or in Phoenix. We also have trucks that we deploy and test very actively. Most of them are around here, some of them, and in Texas. So I'm going to talk about both of these applications today, and let me start with Waymo 1, which is our ride-hailing service. So you can see, like, this is our Waymo 1 service we deployed in variety of cities and multi-geographies. We learn these models and all kinds of things, not just based on hard-coded rules, but more, as I said, ML runs everywhere through the stack, and that's what we use. And the driver generalizes not only to multiple geographies, but also to multiple products. Okay, let's start with Waymo 1, our ride-hailing product. This is a video that the Waymo car has done and driven in SF at the night. Again, note that not all driving is easier. Driving in dense urban is very, very different from driving probably in suburbs, right? So what happens when you drive in dense urban? Notice what's going on if the video plays. Okay. If the video doesn't play, find me later. I'll try to describe what's going on in the video again. What you see here is this Waymo driving. You'll see, those of you who live in SF probably know there are like lots of double parked vehicles that are not parked in the right spots. That's what you see, things that are driving really fast. There are people that are crossing, that are at non-crosswalks or jaywalking pedestrians and cyclists. There are parking garages, things showing up from the cars exiting and entering these parking garages very quickly. What is it that you know? You notice that a lot of times these cars need to drive through very narrow spaces, right? So for safety, let's say you want to be safe, you can hard code a rule that says that let's make this car always keep half a meter distance from any other object. Safe, right? I mean, you kind of think, yeah, it is safe. But what does it give you? It gives you probably no progress. You always get stuck. And worse, you cause congestion and probably other safety issues that you have not anticipated, like tailgater collisions. Other people expect that you drive more normally, and you do it. What does this Waymo driver need to do in dense urban? We want to be safe, but we also want to be responsibly assertive, like human drivers. And that's what our drivers do. Okay. Oh, this video is playing, that's great. So another important and a kind of a long tail kind of situation that you see about 20, there is a red light runner in dense urban every 20 minutes in the US. And you can see if you have an autonomous vehicle, notice just a video. This is kind of the view of what a human driver would notice. There's this red truck that is zooming through a red light, and then the Waymo car is able to very quickly recognize and promptly stop safely for it. It does, if you look at the code, it does recognize the stop sign runner, or red light runner in this case, much sooner than what you probably could see from the cameras. What is also very interesting is to deploy systems in these kind of things, you can't hard code rules, right? So these have to be ML-based systems, and that's what we do there. There are also some really funky ones that you see. If you lived in SF or New York or whatever, you're like, yeah, I know what you're talking about. Cyclists are some of the most fun agents on the road. They're also very challenging. Why they're challenging? First thing is they come in all shapes and sizes, right? You have bikes, you have trikes, you have unicycles, you have tandem bikes, you have trailers. I don't even know what that yellow thing is called, so I'm going to skip it. So you have all these things. These things are very, very relevant and very, very important. They also do like really other funky things. They have very different behaviors on the road too. They have bike lanes. They can drive in the lane of the car. They can split lanes. And sometimes they drive on the opposite side of the road. But we want to be, what is it that we want to do as a Waymo driver? We want our Waymo driver to be very safe, react to all of these seemingly long tail events very correctly and coherently. So let me show you some of the examples that the video plays. So what we see here is kind of Waymo reacting to like what a human would probably do. Oh, again, my video is not playing, so let me describe. What you see here, the Waymo is driving straight, and then there is another truck there that is occupying the bike lane. There are cyclists that are coming from here, and Waymo realizes that probably the cyclists will kind of enter the car lane to avoid this truck on the bike lane. Which obviously that's what they do. The Waymo car reacts appropriately and yields for them and then passes after that. There are also some really other funky and very interesting behaviors. My video is not playing. Okay, maybe I should just give up hope on videos, right? So what's happening here? Again, find me after this is a very fun one. Waymo car wants to go. Oh, Waymo car wants to. Okay, maybe I'll talk about this one. This is really fun pedestrian interactions too. Waymo wants to take a right turn, and in anticipation of that, wants to make a right lane change. It drives around this double parked car, then notices suddenly that there's a human kind of hiding behind the truck. It slightly maneuvers around it safely, then makes the lane change and then takes the right turn. So these are the kind of interactions that you see in the road, and the driver does it absolutely beautifully. I talked a lot about our Waymo one. We also have a Waymo Via. This is our trucking product where we believe in transporting goods from place to place, either on highways or local deliveries. Freeways are. So this is a video of a truck that's driving in very high-speed lanes in around Dallas metro area, from Dallas to Houston, if I'm right. And you see like these lots of motorcyclists that are coming and cutting in front of the truck very, very quickly. Now this is, those of you who have driven on freeways, I don't know how many of you have commercial truck license, but if you do, you'll probably note that this is a very common space, but also extremely challenging to get right. We see them and we react to them very well. All of these tech, hopefully, I've convinced, even without the videos playing very well, is extremely fun. It involves very, very, for those of you in ML, it probably involves extremely high, challenging, and very useful implementation of deep learned models, different ML techniques. Ultimately, at Waymo, all of us might be excited about it, but ultimately what we want to do as a company is to serve our customers, right? We want to make a service that users love, use, rely on, and are delighted by it. And hence we offer our rider-only services or fully autonomous service In Chandler, we are expanding our service to downtown Phoenix and SF. We've done it in in Chandler area for about 2 years, as I said before, and this feedback has been extremely valuable. Most of the feedback is positive, but we also learn from the feedback and enhance our product. I wanted to say that. Let me play one last video. If it plays, can you try clicking on it? Let's see if it works. So anyway, if it doesn't play, what I wanted to show in that video was different user experiences and journeys of what was going on. You'll see very, very varied kind of usage. You'll have a retiree going to a mall. You'll have a mom and child going to a park. You have kids getting picked up from school from parents. All sorts of wide variety of use cases. We hope that over time we build a service that is very awesome and safe, and of course people love something that people love using it. So thank you for bearing with me in spite of not videos. I wanted to show you at least a truck, if not the video. So that's a long truck. That's our trucking platform right now. And then we have ride-hailing vehicles. Happy to take any questions.
Great presentation.
Hi, thank you very much. Great talk. Even the videos that played, they were like cool visualizations. They're awesome. I have two questions. One is, when human beings drive, we constantly make models of other people's intentions, right? And then we react to that, and that's kind of how we do. So does the Waymo car itself have a component of its own intentions, and does do the AI model form that intention, and somehow it demonstrates that to others?
You have asked the perfect product manager for that. That is the part of the technology that I lead from product side, and that is broadly what we capture in prediction. So predictions does exactly that, predicts the intent and the behavior of other users, and then planner uses that information to react to it.
No, what I mean is that is true. So it predicts the intentions of other users on the road. But is there a concept of the Waymo car's own intentions, because its own behavior other people are observing and trying to travel?
Yes,
right?
there is.
Okay, that's cool. And the second question is also how do you handle or what are your thoughts about handling accountability? Right, at the end of the day, no machine learning model is 100% perfect. Mistakes happen. So if I'm driving around on a road and cause a reckless situation, there is people know, okay, they need to come and talk to me, or call the police on me. But if the algorithm makes that mistake, suddenly there's that vagueness, right? So what do we do? So how do you address that?
So I'll kind of tell you what we do. We have a playbook there. This is our playbook that we have deployed in Phoenix, in Chandler area, and we've done it for 2 years very very robustly. The way we do it, before we deploy, we test extensively in simulation. We then use our driving specialist to then test it autonomously, but with somebody on the wheel in case things would happen. Those go through extensive things. Waymo also has published in last year a detail on how we do our safety framework. I would encourage that. Please go to Waymo blog, Waypoint, and find that thing. It's a wonderful reading. We are very transparent. We work with all the government agencies, share our data, and that's how you build the trust. Again, we are in the mission to take people and goods safely and easily. So that is a key concern for us, key responsibility for us.
Thank you. Cool.
Thanks for your presentation. I was wondering, so I noticed that you guys still keeping multiple sensors, and Tesla has obviously decided to only go with vision. Do you have any specifics about the challenges of using multiple sensors and why, if they're necessary going forward?
So at Waymo, we do what is called L4 autonomy. L4 autonomy is when you don't need a driver behind the steering wheel. The car is fully autonomous. If you have an L2 autonomy, like some of the players in the industry might have, they need a human in the loop or human at the driving wheel. So when you are working on an L4 autonomy, it is very important that you are fully covered at all times and at all situations. So far, we have noticed that we need these kind of we need this depth of sensor information to make that happen.
Hello. Yeah. Thanks for your talk. I wanted to ask if you could shed a little bit of light on the evaluation aspect, considering so many millions of miles, so many hours and hours of video recording. How do you handle that, even the examples that you were showcasing, to kind of find those nuggets of interesting insights or good stuff, bad stuff? How do you manage to do that at scale?
Yeah, so I have like a simple word for it. ML models, data science, data analysts, and product managers, right? And we have an extensive operations to deploy our things extensively. We drive in real miles. We simulate a lot of them in things. We create scenarios that we think are very critical for safety or quality or compliance. We have extensive test sets across all these things and metrics for all these things. This is not easy, this is not trivial. That's why you need this kind of development done very responsibly and very focused, with a lot of focus.
Hi, related to the sensor question, so a lot of times with complex processes, we think about what happens when you have a failure point, or in some cases, double jeopardy, where you have two sensing modes fail. Are the algorithms that are trained for the driver, are those also optimized? Or in the event, say, your vision sensor goes out, or the LiDAR sensor?
So I can't give you all the details, of course, but I can give you like a very high-level picture. Of course, if everything is working, you have all information. But both the hardware and the software are built with a factor of safety. What happens when things go off? Can we still drive responsibly? Can we drill safely? We continuously check that. And if ever we are like, okay, we don't have enough information or not the right information, we have mitigations in the software to make sure we have a fallback driver that takes over and still maintains the safety.
Great. Great presentation, Vinutha. Thank you.
Thank you.